quite some time, I've been wanting to do a documentary series on the early days of Compaq Computer Corporation, but there were three very specific machines that I wanted to be able to show. And I've been on the lookout for these machines for quite some time. Well, I have finally acquired all three of them. Unfortunately, all three of them are broken, and all three of them do require cosmetic restoration as well. So, this is going to be the first of a series of restoration episodes, and I'll be starting, oh man, this guy. Whew. This is the Compaq Portable 1. Of course, really it's just called the Compaq Portable, but we kind of retroactively call it the 1 to differentiate it from the number 2 and 3. This is kind of similar to the Osborne in the way that it's packaged. But this machine is kind of special for a few different reasons. One, I actually knew somebody who had one of these back in my high school time. But this was also the first commercially successful IBM compatible computer, as well as the first commercially successful IBM portable computer. So this is a pretty interesting piece of history. So I actually picked this computer up a few weeks ago at the retro computer gathering that we do in Dallas periodically, and I was told it doesn't work, but I have not tried turning it on yet. So let's dig into this thing. Taking a look at the exterior of this thing, it's pretty dirty all over. However, it doesn't look like anything that will be hard to clean, and I don't even think it needs any retrobrite. I'm not quite sure what to do about the thread coming off this leather handle though. However, taking a look at the keyboard, I think it may be different here. The keys definitely look like they need retrobrite, so that should be fun. But on the bright side, it isn't missing any keys. Well, I guess we should plug this thing in and see what it does. Well, here goes nothing. I hear a fan, but there's no activity on the screen, and I don't hear any beeps or movement of the floppy drives. I'll check the brightness. No difference. Okay, I think we can assume it's dead. Let's see if we can revive it. So there are 5 internal snaps to remove this cover, and what you need to do is pop the first one, and then place something in there like another screwdriver to keep it from snapping back down, and then go over to the next one and repeat. Eventually, when you get to the last one, the panel will come off. Looks like there's already a broken snap, and I don't see the plastic piece anywhere laying around, so I think this was snapped a long time ago, but all the rest of them seem to be good. This thing is pretty neat. It looks like each function of the computer has its own little metal cage and cover. So this will get you access to the card sockets. This is the CRT screen, and this section is for disk drives. And it looks like they're mounted on little rubber shock absorbers, which is pretty cool. I wanted to start with the card socket cage, but these are some of the most annoying screws ever. They're flat tipped, but the slit is too skinny for a decent sized screwdriver to fit, and I just wasn't having any luck with these things. So I tried a nut driver, and while I had better luck with that, it was still difficult to remove these things because there isn't much to grip onto. If the heads were just a little bit taller, that would have helped a lot. Okay, well, let's remove the top cover. So, unlike other portable computers, this one is really just like a desktop, and it has 5 ISA expansion sockets, and 4 out of the 5 slots are filled. Next, I'll remove this HV panel. A lot of these covers are just designed to slide off if you loosen the screws a bit. And there we go. I'll also remove this bottom case cover. The first troubleshooting step I always take in the case of a dead computer is to remove anything that isn't essential, so I'll start with this. It appears to be some kind of networking card. IBM Multi-Net Interface. Never heard of this. Next thing is what appears to be a parallel port card. Next up is an old MFM hard drive controller card. Alright, so I noticed there's this little LED power indicator on the motherboard, but watch what happens when I power this thing up. Yeah, it flashes real quick, and then you hear the fan come on. And I noticed the fan itself is powered from AC power, so it really isn't indicative of the power supply working. So I'm going to measure the voltage at the board. See that? When I power it on, there's a short burst of power, and it dies, just like the LED. Okay, so I'm going to keep disconnecting stuff, and this is the cable that runs the internal monitor. So I'm going to remove the video card, and then I'm going to remove the floppy card. Then I'm just going to unplug the power to the floppy drive and the hard drive. The idea here is, I think the capacitors in the power supply are weak, and I want to reduce the load on the power supply. Okay, here's the power LED again. Let's try the power. Hey, we have power. Of course, we aren't going to see anything on the screen because there's no video card. So let's stick the CGA card back in. However, nothing happened. In fact, we're back to the flashing LED again. I felt like maybe the power supply was weak and there just wasn't enough amps to get past that initial starting phase. And I really wanted to see if the motherboard worked before going any further, so I got the crazy idea to use another power supply to sort of jumpstart the thing by giving it a few extra amps. I even asked a few other experts if this would be a bad idea, and nobody could think of a good reason not to. I used some paper clips and just bent them into the right shape so that I could jump all 4 leads from the 2 power supplies. Yeah, I think that'll work. Okay, I'll start by firing up the external supply. Yikes! So that was a bit unexpected. Let's watch that again. It looks like a tantalum capacitor on the video card exploded. You can see it right there. You can also see the black market left on the metal bracket and even on the pin headers above it. Here's the interesting thing. Now that the capacitor blew, the power supply actually starts up every single time now. However, I'm still not getting any video. And I decided to test the voltages again, and this time I'm getting a steady 5.1 volts. Maybe just a bit high, but I don't think it would be a problem. And the other rail I'm getting 12.4 volts. Again, a little high, but probably not an issue. Alright, so I had to sleep on this, and now it's morning, and time to get back to work. Now, let's just take an overview of where we're at in this troubleshooting situation. First of all, I thought the problem was the power supply, and apparently it wasn't. Apparently the problem all along was this tantalum capacitor on the CGA card was shorted, and I guess the power supply here was simply too weak, or its protection circuit was too precise to allow the current to flow through, where this power supply just barreled the power right on through until this thing blew out. Interestingly enough, the power supply is working fine in here now, and every time I fire this on, there is proper voltage at the motherboard and at the Molex connectors for the floppy drive and the hard drive. So I think the power supply may be good, but there's still 3 wild cards, and that is, does this CGA card work? I looked at this capacitor, and it only appears to connect to this external header here, and it doesn't appear to be anything critical on this card. So I don't think that capacitor is a critical component, but I'm still not getting any video, either on the external or the internal monitor. So that raises the questions of, does this card work, does the motherboard work, and does the internal CRT work? I can tell you this, when I fire the computer on now, I see that the heater on the back of the CRT is glowing now, which is a good sign. That does tend to indicate the CRT may be working. So, how do we troubleshoot this? Well, we need to do a process of elimination. Now, I don't have a replacement motherboard that I can try, but I did make some phone calls last night, and I made a late night run over to my friend DJ's house, and he had these. Now, these are CGA cards, but they're not just any CGA cards. They actually happen to be compact CGA cards with an internal header for running one of these internal monitors. Now, you may notice it's a little bit shorter than the original card. I think this is from maybe the 2nd generation of these compact portables, so it's a little bit more compact. A lot of the chips are more consolidated. So, but in theory, it should work. So I'm going to stick this card in there and let's see what it does. The internal header is in a different place, but I think the cable will reach, and it does. So there we go. Let's try it again. Nothing. Still no video, no beeps, no signs of life. I also tried it on an external monitor just to be sure. Still nothing. The next thing I want to do is try one of these postcards. No, I'm not talking about a postcard you send in the mail, but POST stands for Power on Self-Test, and this particular one is designed to work in an ISA slot or a PCI slot. And then it has a readout for any error codes from the BIOS. Also, it has these little LEDs over here, which will show you all of the voltages and all the other information on the bus, including the reset line, so you can see if that's stuck or not. So I'm going to stick this down into the last slot so that it will be easy to see what is displayed. Well, everything looks good, except there are no codes and still no activity. Well, it's time to remove the motherboard. The way you do this is to remove this little panel so that we can disconnect the power supply and the keyboard. And the board simply slides out like so. Well, here it is. The board is somewhat smaller than I expected. I'm a little mystified what these empty ROM sockets are for. I'm hoping I'm not missing something important there. I'm going to go ahead and reseat all of these socketed ICs. I'm not going to remove them. I'm just going to pry them up a tad bit and push them back down in. I'll also do all the RAM chips. Speaking of, I noticed this one here in a socket. Makes me wonder if this RAM chip has been replaced before. I also noticed something else. Check this out. This trace here is burned. This is most likely the 5-volt rail for the ISA sockets. So I thought I should test continuity on the ISA sockets. And yep, it appears there is a break right in the middle. It looks like the 3 slots on the end here are the only ones getting power. So I tried the postcard again in one of the dead sockets, and sure enough, you can see the LED for 5 volts is not lit up. So that socket is essentially dead until I repair it. So I thought I should try sticking the video card in one of the good sockets. And unfortunately, the internal video cable does reach, but still, no dice. The computer is still dead.
Okay, so I went to see my friend Raymond, who is like the Jedi master of electronics repairs, and we were going to look into repairing this board. And he did look at it briefly. However, things kind of took a little bit of a turn when he was digging around on his shelf and finding this, which is actually the exact same board that goes on with these compact machines. I don't know where it came from. He said he's had it there for years. The only problem is he noticed that there was some damaged traces here, probably from something scratching it really deeply. So he added these little patch wires on there to solve that problem. But we fired this board up on the bench and it did work. Okay, also some news on the CGA card. This is the original CGA card, and this is the one that had the capacitor that blew up. Now, when he actually tested this, he found that there was still a short, and the short was actually on the 12-volt line, not the 5-volt line. So what that means is that the trace on the motherboard actually ended up burning out before the capacitor did. He ended up replacing this capacitor, and we tested this on the bench as well, and this card is now working. Speaking of capacitors, remember these 2 cards that I picked up from my friend DJ? Well, it turns out one of them worked and one of them didn't, and I think this is the one that didn't work, and it also had a capacitor that was shorted. It was one of those same little tantalum capacitors, and so he replaced that, and now all 3 of these CGA cards are now working. However, even though this board did fire up, and we couldn't get any further because we didn't have any disk drives or anything connected to it, but there are some interesting differences in this board. First of all, it has a NEC V20 processor installed instead of the Intel 88. And it's a fully compatible processor. In fact, it's actually just a little bit superior, so I guess we'll just leave that in there. However, when it comes to RAM, that's where we've got a problem, because this board only has 256K of RAM, because these are 4164 chips, and the other board had 41256 chips in it.
So I'm going to remove the RAM chips from this first board here. You know, this is something I haven't done in over 20 years, swapping an entire bank of RAM like this. And believe it or not, this was very common on IBM compatible motherboards of the era, whether they be clones or the real thing. SIMs and DIMMs were uncommon on XT class machines and really didn't start to become popular until 386 motherboards. So this was how you upgraded the memory in early PC motherboards, 1 chip at a time. So this is the factory configuration of this board. It comes with 128K soldered to the board, and then 2 rows of expansion, so you can put up to 640K total on this board.
There are 2 sets of dip switches on this board. Now, my understanding is this switch controls settings regarding things like floppy drives and what kind of video card. These are used to configure how much RAM is on the board. However, from what I've read, later versions of the BIOS actually ignore these and do a self-test to figure out how much RAM is in. So we'll see how that works.
Speaking of BIOS, looking at the BIOS chip on the original board, it mentions copyright up to 1986, which is 4 years after this machine was designed. But on the new board I just picked up, it goes all the way to 1987, and this is probably the latest BIOS ever made for this machine. So these are the 4164 chips I pulled out of the new board, and I'll definitely hang on to these. I believe they're compatible with the Commodore 64 and Apple II machines, among others. Anyways, the next thing I need to do is remove this metal bracket from the old board, and then install it on the new board. And then I can install the board into the computer. I'm going to go ahead and use the original CGA card.